shooting method, I can answer that. Please check if there is any problem with shooting method. Then a little bit more general case than this one, because this case is very straightforward and easy because it doesn't require any complicated part here. So I will gradually increase the difficulty by covering harder things. First of all, I will cover the case like this. Right? Independent variable is t. So I will cover this kind of case. This is the easiest case. And then after covering this linear case with like functions I will indicate the function. I will indicate differently. So after covering so I will just include this thing. After covering this kind of case, I will cover the case with nonlinear terms. So will this be general enough? So linear equation cannot have any more complicated terms than these things. Do you follow me or not? Linear differential, the second order linear differential ODE equation, right? ODE cannot have any more complicated parts than these things. Do you agree with me or not? Because if y prime then y are multiplied, then it's not linear anymore. So I guess this is the most general case of linear equation. So let's solve this linear equation, and then after solving this, we will handle nonlinear case. Then we can finish this chapter. So let's assume that we have the same boundary and same breakup like this one. Then y I plus 1 minus 2yi plus yi minus 1 over h squared equals a of ti and y. So instead of using a of ti, I will use subscript. A sub I is way easier to represent, right? And then I will describe a sub I later. A sub I, and then yi plus 1 minus yi over h, and then b sub I, yi, and then c sub I. Do you follow me? Where a sub I is a of ti, b sub I is b of ti, c sub I is c of ti. So I wrote the generic algebraic relation between these yi unknowns. Because we have a differential equation, can you calculate the ai, bi, ci or not? Can you calculate ai, bi, ci? Because a, b, c are given by the problem. You plug in ti values to values, so these are all just numbers. All numbers. So the only thing remaining here is just rearranging it to create simpler form. So I will use lowest order first. Lowest order is this one. This one is the lowest order. So yi minus 1 is the lowest order term. And then yi term will be attached. H squared multiplied here gives us h times this may other. So do we have any more? Oh, EI is ignored, sorry. And then yi plus 1 term should be considered. So 1 here, and then h squared multiplied here, then and then finally ci h squared. So I rewrote the relation. So please take a look and check whether it's just simple algebra, right? When do you handle this kind of a thing in schools? In middle school or elementary school? Middle school. Right, middle school. So I just rewrote it. So I minus 1 term. After multiplying h squared everywhere, I rearranged. So after multiplying I minus term is attached here, and then negative 2, and then minus multiplied by this, it moved, then it's plus h, and then h squared multiplied, and then I plus 1 term, and then h multiplied, and then finally ci, so it's correct. Then instead of writing down for each, I will directly go to MATLAB and solve the problem, but we don't have AI information. So what kind of AI do you want? What AT do you want? What function do you want in the first place? The differential equation can have any function here, right? ABC function. So what kind of function do you want? Log t. And ET is sine t. CT is exponential t, right? So any function can be there. Then we can calculate the value. So I will program this thing to evaluate values. So let's go up and then calculate. Maybe because there are not many values, it's good to just use just a straightforward calculation, right? So let's calculate these values. Thank you. in any case, after calculating these things, I will create the matrix of coefficients, right? Coefficients. Matrix requires these things, so I will make matrices of this sort. So consider the best way to implement these things. Because assume that we have more than 3 unknowns, in other words, 300 unknowns, then how can we automate these things instead of just doing hand calculation? Strange. Do you experience the same thing? Like, that's the only way? But in any case, as you can see, we create the equations like these with a little bit different numbers, right? Instead of this number, we may have a different number. We may have different numbers, right? Instead of this number, we may have a little bit different number. Instead of 0, we may have some number, right? So this is the only difference. And then later we move this to the right side, we move this to the right side. So let's calculate these values. So these are the results. So log result is so we should take the value. So I used wrong value. We don't need this much, just 1/4 to 3/4 is enough, right? So these 3 values. So this is A1, A2, A3. Do you follow me? A1, A2, A3 are found. So please copy these values and let me know, because I cannot write here and then go back and forth. So please write. This is A1, A2, A3, and B1, B2, B3, and C1, C2, C3 will be shown later. So A, B, C. But automating this might be the task, right? Might be the task that you need to consider. So let's calculate, because these can be stored in AI position and H is known, then we may automate the calculation a little bit. So let's try it. Instead of doing hand calculation, I will store these things in some place. So this is A, right? A is stored here. And then B is stored here. And then C is stored here. So A, B, C are stored here. Then we can easily calculate this thing. Minus 2 plus A multiplied by H. H should be stored. So I will store H2. H equals 1/4, right? Then we are ready to just to do this thing. Minus 2 plus A, H, and then minus BH. So we calculate the first. Thank you. I will do it. My last. So we calculate the first, and then we can store this thing to some place, right? So I will copy and store this thing in matrix where, what is the good name? It's the first row of the A matrix. So A of first row and any column, first row and any column equals this thing, right? But this isn't great. But in any case, let's store it this way. After storing in flat form, later I will shift. Do you follow me? So I create the first row. Oh, A is used twice, so matrix might be better. Is there a problem? So it's good to create a matrix, 5 by 3 matrix. So how do we do it? Zeros of 5 by 3 by 5, 3 by 5 column matrix, right? And then we populate the first row and second, first to 3 column, right? Do you agree with me or not? Because as you can see, I will show you. As you can see, if we arrange it, then 1, 2, 3, 4, and then 5 column, right? By 4, right? 5 columns. And later, we will chop first and last column to move, and then we will create 3 by 3. But it does not run. So do you find the problem anywhere? H is 1/4, and T is given, and the zeros are given, and everything looks okay. Do you find the problem and let me know? Yeah, it is populated, right? Do you follow me? And second one will be determined very soon. M 2, 2, 4 is equal to the same thing, or so I am calculating no. So this is not it should occupy the column. What is the order? occupy the column y0, and then y increases each time. So it should be a little bit trickier than just this thing, because we should populate differently. So I completely misled you, because I thought these are coefficients, but this one should be stored, not this kind of pattern. So how can you overcome this difficulty? Then let's make component-wise decision. It's not very pleasant, but at least we can make it this way. So I will use program style thing to populate the values. So let's do it. Let's not worry about the other things. So I will use k for k running from first to the last 3, and then kth row is determined, and then kth row and kth value, k plus first value is determined, right? It is determined by k and then k. So I used the C-style input. Do you follow me? So k's position is at least determined this way. And then and so I will just show you what is populated. So this is populated. Do you follow me? Like CCC before, right? So we should populate this CCC term. And then these terms are 111s, right? So I will populate the terms. So so why do I do this thing? Because in the future, you need to solve a problem with big size, right? Then if you don't automate, you will suffer. You cannot just calculate each value by hand. You should populate. So I'm showing you how to populate the coefficients of these kind of things. The coefficients, these kinds, this one, right? So I'm populating it. Then as you can see, I populated this portion using C-style program, and I will populate this thing using 111, right? 111. So I like this, right? 1, and then 1 moved to that side, right? And 1, right? So this kind of thing. And then later I will write M. And what else? This side should have this thing, right? This side should have this thing. So it is M k row, and then k plus 2 side equals 1 minus A of I multiplied by H. And then finally, the right side, excuse me? Oh, thank you. Thank you. So I'm looking at I, and then, oh, it's a very bad management. But in any case, CI and then HI is the right side. So I will use the right side, right? Right hand side equals 0 vectors of 3 rows and 1 column, right? 3 rows and 1 column. And right hand side of K row, and then first column is determined by C of I multiplied by H squared. So I populate everything by just this routine. I populated entry by entry. Thank you. I should have used I in the first place. Then let's run and then check what kind of thing can you see. So some mistake. Zeros. So this is the matrix that we can get, right? And right side also can be obtained, right? But let's see the right side, and then I will solve. I will show you these things. Excuse me? Oh, it's just a moment. Just a moment. So B is not good. It is right hand side. Right hand side. Save it and then run it. So let's run it. So if we run, then we will see M. Oh, we are not ready to solve. We should chop this part, right? We should chop this part and move this part to the right side. Do you follow me? It is 5 by 3 matrix. We should chop first and the last one and move. I didn't do that, so I will add things here. So how can you chop it? It is like right hand side of 1 first row, first entry is equal to current right hand side of 1, 1 minus M of 1, 1, right? So I chopped and then moved, right? And then similarly, right hand side of third entry and first one is right hand side of the third entry and first one minus M of 3, 1. And then now M should be reduced. It should not include the first and fifth column. So I shrink M. I chop. Yes. 3, 5, right? 3, 5. Oh, 3, 5. Thank you. In any case, I'm somehow suffering but found the representation. In any case, we fixed problems and then let's solve. So these are the solutions we obtained. So take a look. So initially, we had, but we lose all the intermediate information. So I will type M here, and then I will type B here, and then afterwards we will see the result. So I will save and then run it. I will show you intermediate result. So take a look. We are running it. Then take a look at the function. We have A, right? A representing 3 values calculated at 3 points. And then B values calculate 3 values. And then C values calculate, function C calculated 3 values. And then M matrix populated using the pattern given by, derived from the differential equation, right? Using this pattern, right? Using this pattern, we create this kind of things. After creating this kind of thing, we chopped this portion and then subtract, right? Chop this portion and subtract it. I should have typed right hand side, not B. So bad usage. So we calculated M, and then we found the right side like this, right? Right side derived from the difference equation like this, right? Right side. Because of the H multiplication, it cannot be very big. Now, right side added by or subtracted by these numbers has this pattern, right? Because of the subtraction. Then, now we are ready to solve, right? We are ready to solve this kind of system. M times 3 unknown heights y1, y2, y3 is equal to the right side like this. This should be solved. Then we can get these heights. So I solved the differential equation using 3 nodes. But can we expand this thing? So did I make the program robust enough or not? So if I want to expand, then first of all, I should use, for instance, some letter such as this one, n, right? And then n could be n could be 100, right? N could be 100. Do you follow me? So I break up the interval into 100 subintervals. Then H is this. Then this can be rewritten 0, 1 over n is the starting point, and then 1 over n is the increment, or H is better, right? H is the increment. And then 1 minus H is the stopping one, right? And then we can create ABC vector. Do you follow me? So we can, I'm just making this program robust enough. So I'm just changing the program completely to handle general case. So I'm showing you how to generalize the program that you may create. Then this is general enough, right? It will break up the interval into 100 pieces and do the calculation. I used 3. I used 4 subintervals in hand calculation, but assume that you need to break up to 100 pieces, then I do it. But because of the possible confusion, I will suppress a lot of results. I will suppress almost all the results, but the solution. So did you see any problem? And is this robust enough? But 100 is too much. I will change this to 10, right? Because I want to show you the result. So let's run it. So this is the result. If we break up the interval into 10 subintervals, then we need 9 highs in between, right? 9 highs. So assume that we break up this into 100 pieces. Can the computer handle it? Of course. Take a look. It handled already. 100 highs, right? 100 highs will calculate. If we break this up into 1,000, can it handle it? Of course. Handled. 1,000 highs were calculated. So if you make the program robust enough, by just really changing the top line, you can do it, and then you can make a function. Like n is the input, then it does this thing, and then do this. I showed you the example of handling the case, and by using function handles, it doesn't have to be specific. You can just call function handle A, and then B and C, and then you can generate all these things. I completely showed you the theory and the implementation. If you don't have a question, then I will briefly mention about the more generalization. You mean this one? This is the crux. This is the crux. And then we chop these parts. These things are only for presentation, so we don't need to, in fact, present these things at all. Just this is enough, right? These are enough to calculate. So I will re-explain the idea. First of all, we break up the given domain using n minus 1 subnode, right? N minus 1 nodes, right? N minus 1 node location is stored in T vector. So T vector has n minus node information. And we calculate the function values at those nodes, right? Those nodes, and store those vectors at A, B, C. And then we create the initial matrix having non-square size, right? It has more columns than necessary. But in any case, we create the M matrix and the right side. And by following the differential equation given by the problem, we created this kind of relation, and then we can create the pattern like this inside the matrix. So inside the matrix, we create the pattern 1 from this, right? And then this part is implemented here. And then this part is implemented, and then this part is implemented in the subsequent, right? This part is implemented and this part. So you implement each part and correctly locate them using C-style programming. And then after populating all the necessary coefficients, we want to chop the number part, because number was used for convenience. Number was labeled for convenience, but they are not unknowns. So we should chop numbers. So we chop the numbers and then subtract those numbers from the right side. And then we chop it. So we don't take the first column or m plus first column. We chop first column and m plus first column. We take second column to nth column and then shrink the matrix to a square matrix, m, and then we solve this to solve this equation. Today I will do the evaluations. I need a volunteer to collect the forms and then return. And I will be in my office so that I can answer your questions, because some of you may need to leave early, some of you may have questions. So you may do this early and come to my office to ask questions. So, yeah. That's right, that's right. So in this case, we use the boundary values, and take a look. The boundary values were, I used just 1 or some number. What is the number that I used? I used 1 and 1, right? So let's check it then. Yeah, instead of hurrying up, we have plenty of time. So let's check what y values were used. I didn't even provide any value. So, in fact, good part. So, in fact, I should correct this thing. We do not subtract m11 or m this one. It is alpha and beta that might represent, right? Alpha and beta, which are given by the problem, right? Alpha is the initial position, such as 1, and then beta is the good pointing, right? I just subtracted 1 and 1, but this portion is for generic 1, but ignore these things because they are chopped anyway. They will be chopped anyway. Do you follow me? Instead of storing alpha in the first position and then storing beta in the last position, I just store any junk and later chop for programming purpose, right? And then I just subtracted this alpha value and beta value. Good observation. Then let's resolve it. I resolved it, and then in any case, you found the problem. And alpha and beta should have been used in the position of y0 and yn. I just plugged in 1 and I plugged in some value, right? Some value of this calculation, even though these are not valid for the last position. Good observation. In any case, now it is perfect, right? So when you create the program like this, you use input variable n, and then alpha, beta. So these are all input. Then it calculates, and then result is coming out. I need a volunteer to collect the forms and then administer these things. And thank you very much. Once I leave, you can do these things, and please return these things to the office and also pencils. I will save it and leave the